Download this code from codegive.com, link in the description below. OK, let's dive deep into the grammar challenge from Hackthebox's web track. This challenge focuses on exploiting cross-site scripting, XSS, vulnerabilities within a web application that's seemingly designed to check the grammatical correctness of user-submitted text. Understanding the challenge. The core premise is simple: you're presented with a web page where you can input text. The website promises to analyze your input for grammatical errors. However, as with many web challenges, the grammar checker is a facade, masking a potential XSS vulnerability. The goal is to inject malicious JavaScript code that gets executed in the browser of someone viewing the page. Challenge setup. 1. Initial inspection *. Browse to the challenge URL provided by Hackthebox. 2. Analyze the input form *. Look at the HTML source code of the page. Pay particular attention to the input field's name, example text, input, grammar. Any surrounding tags or attributes. Any client-side JavaScript code that might process your input before sending it to the server. 3. Observe the output *. Enter some basic text and submit it. Examine how the text is displayed on the page after submission. Does it appear as is, or is it modified? Look at the HTML source of the response. Is the submitted text directly inserted into the HTML structure? Identifying the vulnerability, XSS. The key to this challenge is usually that the website naively inserts the user-provided text into the HTML of the resulting page. This opens the door for XSS attacks. Reflected XSS *. Your injected script is part of the URL or form data submitted by the user, and the malicious script is reflected off the web server, such as in an error message, search result, or any other response that includes some or all of the input sent to the server as part of the request. Exploitation strategy: crafting the XSS payload. 1. Basic injection test *. Start with a simple XSS payload to confirm the vulnerability. Enter this payload into the input field and submit the form. If successful, you should see an alert box appear in your browser displaying the text XSS. If you don't, the input is likely being sanitized or filtered in some way. 2. Bypassing sanitization / filtering *. HTML encoding *. Sometimes, the website might try to prevent XSS by encoding characters like, etc. Try using HTML entities instead. Many browsers will automatically decode HTML entities before executing JavaScript. Case sensitivity *. See if the filtering is case sensitive. Try attribute injection *. Instead of injecting a script tag, try injecting an event handler into an existing HTML tag. For example, if your input is placed within a div tag, try this. The full HTML might look something like this on the server side. When the page loads, the onload event handler will trigger the alert function. Image tag with one error *. This attempts to load an image from a non-existent source, src = x. The one error event handler triggers when the image fails to load. Script tag with src *. This pulls JavaScript from an external source, your server, allowing you to bypass filtering on the input field directly. You'll need to host the evil.js file on a server you control. This is often very powerful but can be detected more easily if the application monitors outbound requests. Data URI *. This uses base64 encoding to obfuscate the alert, XSS, command. @hub decodes the base64 string, and eval executes the resulting JavaScript. Using alternative JavaScript handlers *. 3. Escaping asterisk. The challenge might involve escaping certain characters with backslashes, backslash. Double escaping techniques can sometimes bypass such protections. Try injecting a payload where you escape the backslashes themselves. If the server converts to backslash, then try script alert, XSS/script. If that fails, try script alert, XSS/script. 4. Character limit asterisk. If the input field has a character limit, you might need to shorten your payload or break it into multiple submissions. Consider using fetch, or XML HTTP request to load a larger script from an external source. Stealing information, beyond alert boxes. Once you can execute JavaScript, you can move beyond simple alert boxes. Here are some common goals and techniques. Asterisk cookie stealing. Asterisk stealing cookies is a frequent objective. Cookies often contain session identifiers that can be used to impersonate a user. This code fetches a URL on your server, appending the victim's cookies to the URL. Your server logs will then contain the stolen cookies. Asterisk redirecting the user. Asterisk you can redirect the user to a malicious website. Asterisk keylogging. Asterisk you can inject code that captures keystrokes from the user. This is more complex and can be difficult to implement reliably. Code examples. Here's a more complete example, demonstrating how to steal cookies and log them to a server. 1. Your evil server, Node.js example. Create a simple Node.js server. You'll need Node.js installed. Save this as evilserver.js and run it using node evilserver.js. 2. The XSS payload asterisk asterisk. Replace http// your IP 3000 with the actual IP address of your server. Important considerations asterisk. Asterisk HTTP versus HTTPS asterisk. If the target website is using HTTPS, your injected script must also use HTTPS when making requests. Example fetch, https / your IP 3000 / log. Otherwise, the browser will block the request due to mixed content security policies. Asterisk cross-origin resource sharing. CORS is a security mechanism that prevents JavaScript code running in one domain from making requests to a different domain. If the target website has a strict CORS policy, you might not be able to steal cookies directly. In such cases, you might need to find ways to bypass CORS, which can be complex. Asterisk content security policy. CSP is an HTTP header that allows website administrators to control the sources from which the browser is allowed to load resources, scripts, style sheets, images, etc. A strong CSP can make XSS exploitation significantly more difficult. You'll need to analyze the CSP header to see if you can find any ways to bypass it. Common CSP directives to look out for asterisk. Asterisk script src asterisk specifies the allowed sources for JavaScript code. Asterisk style src asterisk specifies the allowed sources for CSS style sheets. Asterisk img src asterisk specifies the allowed sources for images. Asterisk connect src asterisk specifies allowed origins for fetch, XHR, WebSocket, and event source connections. Asterisk default src asterisk a fallback directive for other fetch directives when they aren't specifically defined. Asterisk unsafe inline asterisk allows the use of inline JavaScript and CSS, generally discouraged. Asterisk unsafe eval asterisk allows the use of eval, and similar functions, generally discouraged. Asterisk nonce asterisk a cryptographic nonce, number used once, that must be present in script and style tags for them to be allowed. Asterisk hash asterisk a cryptographic hash of the script or style content, which must match the hash in the script or style tag. Bypassing CSP. 1. Finding a whitelisted source *. If the CSP allows JavaScript from a specific domain, you might be able to host your payload on that domain. This is often difficult but can be possible if the whitelisted domain has an open redirect or other vulnerabilities. 2. JSON endpoints *. JSON, JSON with padding, is a technique that allows cross-domain requests by wrapping the JSON data in a JavaScript function call. If the website uses JSON endpoints and you can control the callback function name, you might be able to inject your XSS payload. 3. DOM clobbering *. DOM clobbering is a technique that can sometimes be used to bypass CSP by overriding built-in JavaScript objects or properties with attacker-controlled values. This is a complex technique and often requires a specific configuration of the website. 4. Finding vulnerable libraries *. Certain JavaScript libraries are known to have XSS sinks. If your target website is using such a library and allows arbitrary JavaScript to be run, then you might be able to craft a payload that uses one of the sinks to execute XSS. 3. Defensive measures *. How to prevent XSS. Input validation *. Thoroughly validate all user input to ensure that it conforms to the expected format and data type. Reject any input that contains invalid characters or patterns. Output encoding *. Encode all user-provided data before displaying it in the HTML of a web page. Use appropriate encoding methods, example HTML encoding, URL encoding, JavaScript encoding, based on the context in which the data is being displayed. Content security policy, CSP. Implement a strong CSP to restrict the sources from which the browser is allowed to load resources. HTTP only cookies. Set the HTTP only flag on sensitive cookies to prevent client-side JavaScript from accessing them. Regular security audits. Conduct regular security audits of your web applications to identify and address potential vulnerabilities. Important notes. Legal considerations. Always obtain permission before attempting to exploit vulnerabilities on websites you do not own. Unauthorized penetration testing is illegal in many jurisdictions. Ethical hacking. Use your knowledge of XSS and other vulnerabilities for ethical purposes, such as identifying security flaws in your own web applications or helping to improve the security of the Internet. Let me know if you'd like me to elaborate on any specific aspect of this challenge or XSS in general. I can provide more examples, discuss more advanced bypass techniques, or delve deeper into security best practices.